All right, so we're wrapping up chapter 12 today, at which point we're going to have our review on Tuesday, and then, tomorrow, and then your test is going to be on Thursday, so your homework is due on Thursday. The second half, I have a couple people who need to do makeup quizzes or retakes, so I'm going to let them do that during the second half tomorrow. So if you have something else you need to work on, you can bring it for the second half. That includes geometry homework. Which is due the day of the test on Thursday. So if you have not done any of the homework, that's what you should be doing on Tuesday, tomorrow, during the second block. Okay, so we are going to skip over tessellations, actually, which is 12.6, which is why you might look at the rewind that's on your actual slides and think, I've never seen this before. You haven't. Don't worry about it. It's not going to be on your test, okay? So we're not doing tessellations. We're going to skip to dilations, because that's a transformation that goes more in line with what we've been working on. Tessellations is pretty much just like repeated tiling, and I think they're hard to draw, and I don't think there's enough bang for your buck. Like, I don't think the payoff is worth it, so we're going to skip over that. Okay, so what is a dilation? It gets bigger? Okay, it either gets bigger or it gets smaller. And there's two types of dilation. It's either a reduction or an enlargement. So reduction means that it reduces, gets smaller, okay? And enlargement means that it gets bigger. All right, and so if something is dilated, that means it's getting bigger or smaller at the same rate, okay? So the size changes, but the shape doesn't, and the proportion doesn't also. So the dilation is a transformation that changes the size of a figure, but not the shape. So which one of these appears to be a dilation?
That one. Wait. Which one's the first one? Like, is it that one? The first one?
It doesn't matter. Because it could be,
dilation.
But it could be a reduction or an enlargement, so it doesn't matter which is your first one. But do the shapes in A appear to be a dilation? Yes. What about B?
No.
What's wrong with B?
It looks like that.
So the actual height of this B doesn't look any bigger, but what happened to the length of it? It got longer. So it essentially was just stretched out, like it became more of an L. All right, so that one is not a dilation. Is that any transformation that we've seen?
No.
No, because all the transformations we've seen, what has been consistent about the shapes? They've stayed the exact same shape. So this is the first one that we're seeing that there's any sort of change in the shape, but that change is only in size, not in actual shape of the figure. Okay, so we dilate figures in the coordinate plane using scale factor. What is scale factor, do you think? Yeah, exactly. The rate at which it gets bigger or the rate at which it gets smaller. If it's getting bigger, the scale factor is going to be greater than what? Not X or Y, greater than 1. And if it's getting smaller, that means the scale factor is no. Smaller than 1. So between -1 and 1. So it's basically what type of number? Decimal point. Okay, so a decimal point with a 0 in the front, or a fraction, a proper fraction. So pretty much scale factor, if it's getting bigger, is either greater than 1 or smaller than -1. And if it's getting smaller, that means it's between 1 and -1. So it's some type of decimal number, but it's got to be less than 1. All right, so if you want to use scale factor, one place that you've probably used it is on a map. How have you used scale on a map?
Because a little distance thing, you
Okay,
scale.
tell me what you mean by that.
Okay, so you have to you get like a little rule or something, and you'll be like,
Yeah.
okay, that's like that. So you go like that.
Okay, so it'd be like on a map, something that's 1 inch is actually
Like 30 kilometers.
like 30 kilometers or whatever away, right? And again, why do they do that on maps?
Because we're not going to get the whole thing.
Yeah, you can't do the actual size, or how big would the map be?
Like the whole thing.
It would be as big as the city, which would defeat the purpose of having a map, because if you could get somewhere without the map, then you would just do it without unfolding the 30-kilometer piece of paper to begin with, right? So scale, the purpose of dilating a shape is to keep it on the same scale. So like Miguel was saying, you take a ruler and you measure 1 inch, and you know that 1 inch is equal to 30 kilometers. So if on a map something is 5 inches apart, then what would you do to figure out how far it is?
I lost count.
Where didn't you say 30?
30
Yeah,
kilometers.
so we're just doing 30 times 5, which would be, what do we call 15 0? Okay, 150. So it'd be 150 kilometers away. So then, again, to extrapolate from that, what do you do with the scale factor? What kind of math?
Multiplication.
Multiplication, good. So you do multiplication with the scale factor. So we use the letter K to stand for scale factor. So when you see K, that means that you're multiplying by that number. So take a look at this initial pre-image. Again, is our first image. So that's P right here. And then P prime is just Kx and Ky. So basically it takes X and it takes Y and it does both. Does what with them?
A lot.
What happened to X and Y when it went from P to P prime? You add K, but you're not really adding it. You're doing what? Multiplying both of them by K. So basically all you're doing is multiplication here. Sometimes if it's getting bigger, you're multiplying by a number bigger than 1. If it's getting smaller, you're multiplying by a fraction or a decimal. And again, all of these are way easier when you put them on a coordinate plane because you can actually see what's happening. But take a look at these 4. I want you to tell me if you think they appear to be a dilation. So this is just a yes or no question. So at your boards, do these 4. Okay, so we dilate things then by applying a scale factor. Now, if a scale factor is negative, that means all the x and y values would do what? If the scale factor is negative, what would happen to the x and y's? They would become negative. If x flips and y flips, what happens to the image? It reflects over this line, or you could consider it a what?
Rotation.
How many degrees?
180.
180, so like 2 turns, right? So when it's a negative scale factor, that's essentially a rotation by 180 degrees. So take the initial pre-image, which is the blue one. What happened with the green scale factor? Was that a positive or a negative scale factor?
Positive.
Positive. How do you know that? It got bigger, but it didn't what? Didn't move, didn't rotate at all. And then what happened with K? It was negative, so it got bigger and it also basically flipped over that x equals y equals negative x. Okay, so if I draw this pre-image with vertices A, B, C, and under a dilation with a scale factor of -2, is that going to get bigger or smaller?
Bigger. Small, bigger.
Bigger. It's going to get bigger because you're multiplying everything by 2, but it's -2, but it's also going to do what? Flip. So wherever it is, it's going to rotate 180 degrees. So it starts at -1, 1. So -1, +1. Then -1, -2. And then -2, -1. Okay, so this is what figure?
A triangle.
A triangle. Now, how do I figure out where the dilation goes?
Oh, we're the 2 and then do the line thing, no?
Be the line thing.
I don't even have to do a line thing because I'm just applying the scale factor. What's my scale factor?
Negative.
So what do I do with that number?
Do -2 all.
Do what with -2 on all of them?
If you add them, subtract. Two.
Bianca? Scale factor means I multiply. So you multiply all the numbers by what?
-2.
So A prime would then be what?
Two.
+2?
Yeah.
And
-2.
-2, because 1 times -2 is -2. B prime would be +4, +2. And C prime would be +2, +4. Okay, so we're multiplying every single number by the scale factor. And if the scale factor is -2, that means all your signs change and you multiply by 2. So -1 times -2 is +2. +1 times -2 is -2. So then I just plot that. So I go 2, -2, and that's A prime. B is 4, +2. And C is 2, +4. So it's the same shape. It got bigger, and it did what? Rotated. Okay. Questions? Yeah.
I thought if you multiply by a negative, it gets smaller.
No. If you multiply by a number greater than 1 or less than -1, it gets bigger. So the only time it gets smaller is if it's between -1 and 1. So like 0.5, 0.25, -0.3.
So if it's a fraction or decimal.
Yeah, but I don't want to just say fraction or decimal because 1.5 is also a decimal, but that would get bigger because it's bigger than 1. So it's like bigger than 1 or smaller than -1. So it's a really little window of numbers where it gets smaller. Not right now. Okay, so you can think of it, Bianca, like this. -1 and 1. Like all of these, it's getting bigger, and all of these, it's getting bigger. Right in here is where it's getting smaller. So between -1 and 1. So it's not that many numbers, but they will have a fraction or a decimal. I just don't want to say only fractions and decimals because technically there are a lot of other fractions and decimals.
Yeah.
Okay. All right, so how would we do this one?
Wouldn't you do the reciprocal of a skill factor?
No.
Oh, just
You plot the first one and then you just multiply all of them by 1/2, which is the same as either multiplying by 0.5 or dividing by 2. So is that what you meant by reciprocal? Yes, okay. So either multiply by 1/2 or divide by 2. Do you have to plot the original? No, you don't have to. I'm not going to make you plot the original, so you don't have to if you don't want to. So if we just did the new one, then all I would have to do is take all of these numbers and divide them by what? 2. It's not negative, so do any signs change? No, they stay the same. So -2 would become 4, 2 would become 2, 1. 4, -2 would become 2, -1. And then m would become -1, -1. So now I have to plot these. So j prime is -1, +1. K prime is 2, 1. L prime is 2, -1. And m prime is -1, -1. What shape is this?
a square.
The square.
Why is it a rectangle, not a square? They're not exactly the same. So how tall is it? 2, and how long is it? 3. Okay, so it's 3 long. Looks kind of like a square, but is actually a rectangle. Okay, so the original then would have been bigger or smaller than that? Bigger. So it would have been bigger than that because the scale factor was what? 1/2, which means our new image got smaller. Yep, it got smaller. Did it flip or rotate at all?
No.
No? So then the new image would be where
Like surrounding it.
the old image would be surrounding it, right? The new image is inside of it. Very good. Yeah. So if you do not rotate it, it doesn't change position. So the center would be almost in the same spot. Okay. All right. What would change here? Describe to me what would change here. We're not going to plot it. Describe to me what would change here. If the scale factor is -1/3, what would happen? Get smaller and so that means what happens to the actual shape? Rotates how many degrees? 180. Good. So all the signs would change. And here, because it's 1/3, that means I would divide by 3. Okay? Or multiply by 0.3 repeating, but I think dividing by 3 is probably easier. Okay, do these two at your boards. You only have to do the new shape if you do not want to do the old.